Math 110, Solving Equations and Inequalities with Absolute Value, Sections 3.5. Now, when we have equations with absolute value, the definition of the absolute value says that no matter what our expression is, what's on the inside equals a positive value and a negative value. Okay? What's on the inside equals a positive value and a negative value, which is why here it says that that expression equals the negative version or the positive version. Now, the other thing to this is we also know that whatever it equals has to be greater than 0. So it has to be a positive value. So for this first example here, this says the absolute value of x. I know that this is going to be, by this definition, has to be the negative version and the positive version. So I can say x is -5 and x is +5. And that's going to be my answer. Now, if I wanted to verify this, if I plugged in -5, absolute value -5 is +5. If I wanted to plug in the +5, the absolute value +5 is also +5. Example number 2. Now, what the definition says that the expression inside the absolute value. Now, if you notice in the definition here, going back, that is by itself. That is isolated. And so going forward, we have to make sure that this absolute value here is isolated. So I want to add the 1 to both sides. So I get the absolute value of x minus 3 equals 5. Now I can say that what's inside the expression equals the negative version, and what's inside the expression equals the positive version. Add 3 to both sides, x equals -2. Add 3 to both sides, x equals 8. And this would be my solution. And you can verify that by plugging both a -2 and a +8 inside, and then you would get 4. Example number 3. I gotta isolate and get the absolute value portion by itself, so I'm gonna add 5 to both sides. So I'm gonna get 2 absolute value of x plus 3 equals -2. Divide everything by 2. I get the absolute value of x plus 3 equals -1. Now here's an issue. We said that an absolute value cannot equal a negative number. So because this expression says this absolute value equals a negative number, I have no solution. And that would be my answer. Now for inequalities, it's going to be a little bit different. Whenever I have my absolute value being less than a, then I have to write it as an and statement. So the expression is going to be in between a negative and positive a. When the expression is going to be greater than a, I write it as an or statement. So it's going to be less than the negative version and the positive version. Notice this piece is the same as this one. When I changed it to negative, that changed directions. And just understand that this works for both the greater than and less than, equal to statements. Now the way that I kind of like remember this is I'm going to say less than, and then I say greater. So it kind of like helps me remember. Less than, it's going to be an and statement. Greater, it's going to be a greater statement. So here I have the absolute value of 3x plus 2 is less than 5. So because it's less than, I'm going to make this as an and statement. So what I'm going to say is 3x plus 2 is going to be between the +5 and -5. Because that's what the definition said that I need to do. Now I need to solve for x. So get x by itself. I get -7 is less than 3x, which is less than 3. Divide everything by 3, and I'm going to get -7/3 is less than x, which is less than 1. So this would be my solution. Now if I wanted to graph the solution, I could put these values on a number line. There's 7/3, there's +1. open circle because there's no equal to, and an and statement you shade in between. If you wanted to pick a value like 0, you can verify its truth because 0 exists between -7/3 and +1, so that would work. If I wanted to write this as interval notation, I would say it'd be between -7/3 and 1. And I would use parentheses because there's no equal to, it's not closed circle. Example number 5 says solve and graph the solution set. This time it says that absolute value of 5 minus 2x is greater than or equal to 1. So greater. So I'm going to write this as an or statement. So but the definition says that we're going to have the same thing, and then the second one is going to be flipped. So now from here we just solve for x. So we subtract 5 on both sides, and I get 2x is greater than -4. Divide everything by -2, and I'm going to get x is less than or equal to +2. On this side, divide or subtract 5, I get 2x is less than or equal to -6. Divide everything by -2, and I'm going to get x is greater than or equal to +3. And so now, solving, or being able to graph this, because this is an or statement, I have x is less than 2 and x is greater than 3. So solid circle, and it's everything greater than 3 and everything less than 2. And if I wanted to write this as interval notation, I could say -infinity all the way to 2, union from 3 all the way to +infinity, which would be my answer. If you have any questions, please leave them in the comments.